Hi students, welcome to physics class. This is Sheikh Mukhtar Ahmed. Today's topic is the chapter refraction of light, and the topics to be covered, that is problems on refractive index, and we have that is the problems of refractive index we are going to discuss, and then after that we are going to discuss an applications on total internal reflection, as we have already studied this topic, total internal reflection, and also the topic of refractive index. I will revise a small about this refractive index. What is refractive index? It's a bending of a light. How the light is bending, how much it is. N is equals to how much, means N means refractive index. In the same way, total internal reflections, we are going to see some applications where we use this kind of technology or this kind of process or this kind of phenomenon. Let's start with the first of, that is problems on refractive index. Here, the first problem: what is the refractive index of the medium in which the speed of light is 1.5 times 10 power 8 meters per second? So, what is the refractive index? Means we need to find N is equals to how much? Of the medium in which the speed of the light, speed of the light denote with c, which is equals to, he has given basically the speed of the light is how much? 3 times 10 power 8 meter per second. This is the speed of light. And the medium which it is, means the speed of the light in the medium is 1.5 times 10 power 8 meter per second. Means, for example, take a beaker or something else. We have some liquid like this. Now, a light ray is coming and it is entering in one medium. Here, the speed of the light is c, that is nothing but 3 times 10 power 8, and the speed of the light in this medium is v. Now, how much it is bending? That is N. N is how much? We know the formula of the refractive index. The refractive index formula, that is N is equals to C by V. This is the basic formula. Now we are going to substitute. What is C? 3 times 10 power 8 meter per second, which is divided by 1.5 times 10 power 8 meter per seconds. And meter per seconds cancels, 10 power 8 cancels, and remains 3 divided by 1.5. If we divide this, we will get the value 2. The refractive index N is equals to 2. So, what is how much it is bending? The ray which is bending, it is bending the how much it is bending? It is bending N equals to 2. That is the refractive index. Next, we have one more problem. The second problem, the speed of a light in an unknown medium. We don't know the medium, that's why V is equals to, this is the medium, V is equals to 1.76 times 10 power 8 meter per second. Basically, we know the speed of a light in a vacuum is 3 times 10 power 8 meter per second. What is asking? Calculate the refractive index. Means how much it is bending in the medium. How much it is bending in the medium. As we know the formula for the refractive index. What is the formula for the refractive index? N equals to C by V. From this, N is equals to, C is how much? 3 times 10 power 8 meter per seconds, which is divided by the speed in the medium. How much it is? 1.76 times 10 power 8 meter per second. Now meter per second cancels, 10 power 8 cancels. If we divide this 3 by 1 by 6, you will get the value 1.7045. Basically, we have seen the units for the speed of the light is meters per seconds, and the speed of the light in some medium is meter per second. Many quantities has units, but here the unit for the refractive index. Unit for the refractive index, we don't have no units. No units for refractive index. Okay, these are the two problems. Next, we shall go for some applications of total internal reflection. One of the application we can see total internal reflection in the prism. In the prism. As here we have a diagram prism. If we allow the light rays to pass over here, we can see this here a source of a light. The light which is coming from the source, it's though both are parallel, it is going in a straight and it is hitting to the one surface of the prism. As it enters, it is interacting with a slope of a line, a slope which has 40 degrees. When it touches to it, it reflects, and it also, when it reflects, the angle will be 90 degrees. Means what's the major concept of this diagram here? See here, the light ray which is entering, it is reflecting inside itself. It is not passing outside from the first interaction. First, as the light ray enters inside, it touches to the surface and reflects. Inside itself, we can see the internal reflection. Here, there is an reflection inside an material, inside and medium. This is a prism made up of glass. This is a prism made up of glass crystal. It has a medium. In that same medium, means like you can say denser medium. We can say this is a denser medium when you compare to this medium. This is an air. This is an made up of glass. Glass means it has some crystals material inside. Means inside, when the enters the light, inside itself it is reflecting. That's why we can say it is the concept of application of total internal reflection. See here, many optical instruments use right angled prism. See here, what is the prism here? 90 degrees, which makes the prism 90 degrees is right angle. To reflect a beam of light through 90 degree or 180 degree. 90 degree or we can say slope of the line, which is nothing but straight 180 degree, by total internal reflection. Where we can see this? We can see in cameras, we can see binoculars, we can see in periscopes and also telescopes. Cameras, I think you know, as we use the mobiles, in the mobiles also we use different types of prisms for camera shoot, and also binoculars, seeing where we use for look and for objects, and the periscope and also telescope. Periscope and also telescope, these are the objects where we see for objects. Different, it's in different constructions. One of the angles of the right angle prism is 90 degrees. Here we can see this is 90 degrees. When a ray of light strikes a face of a prism, this is the face of the prism, perpendicular. How is this? Perpendicular. It enters the prism without deviation. Is it deviating? No, it is not deviating like this. It is directly, it is entering and strikes the hypotenuse at an angle of, this is an hypotenuse which makes an angle of 45 degrees. Since the angle of incident is 45 degrees, this we can say this is an angle of incident 45 degrees is greater than the critical angle of the glass. Greater than the critical angle of the glass, which is 42 degrees. The light is totally reflected by the prism through an angle of 90 degrees. Two such prisms are used in periscope. In a periscope, we use two prisms like this. The light is totally reflected by the prism by an angle of 180 degrees. Two such prisms are used in binoculars also. Let's have a small one more example here, that is total internal reflection used in optical fiber. What do you mean by optical fiber? As we have internet connections through the cable connection, in that cable how the electromagnetic waves are passing, how the light rays are entering. So this is the diagram where we can see the light, how it is entering. See here, the total internal reflection is used in the fiber optics, which has a number of advantages in the telecommunication field. As we are using telecommunication, we are using the data internet package, the cable connections. As the rays are entering from the cable, how it passes, that is the diagram here, consists of hair size thread of glass or plastic inside the cable. Now see the diagram here, how the light is entering here. This is the light ray reflecting inside itself. It is not going outside the cable. Reflecting inside, reflecting inside, reflecting inside, reflecting inside, reflecting inside. So all totally internal reflection. That's why we can say this concept is an total internal reflection. Inside we can call as an core, the outside we call as an cladding of an cable, fiber optic cable. What type of connections we have at home? Internet, fiber optic connections, means which we use cables. Nowadays the technology increased, mostly we are using Wi-Fi's. Okay, fine. Next, which light can be traveled? The inner part of the fiber optic is called core, this one. Carries the light, and an outer concentric cell is called cladding. This is the cladding. The core is made up of glass or plastic. Mostly we see plastic. If you cut the fiber, we can see mostly plastic. Very rare cases we see the glasses or a relatively high index of refraction, some materials like plastic materials. The cladding is made of glass or plastic but of relative low refractive index. Light enters from one end of the core. This is the one end of the core. Strikes the core cladding boundary at an angle of incident greater than the critical angle and is refracted back into the core. In this way, light travels many kilometers with a small loss of energy. In this way, it travels many kilometers. We can see cables or through the roads to the from one pole to the another pole, as we can see the cables. from one place to another place, from so long it travels with a loss of very small amount of energy. See here, this is a binoculars. We can say a pair of binoculars. In this also, if you take this part, one part, because saying pair, right, I am taking only one part. Inside also we can see the same design. See here, as the light is entering from one lens, or we can say glass, it's a glass, just a glass. See, there is a prism, right? What's happening? First, it reflects inside. Reflects inside, again reflect, and enters into the another prism which is kept in opposite, reflects. See here, the concept total internal reflection inside itself. Here total internal reflection, total internal reflection. These are the concepts where we can use in the binoculars. So what kind of technology where we use in the optics technology in the binoculars is total internal reflection technology. Means it reflecting inside the same medium. That's why it is called as a total internal reflection. It's made up of glass. It's made up of glass, normal glass. It's called as a prism. Mostly prism will be of 90 degrees or 60 degrees. Right? We can say this is about 60 degrees. This is 90 degrees. This kind of prisms we use for the real life, for constructing many things. If you see projectors, I think everyone knows projectors, which projects the light rays, colors. Basically light in the projector, we have different types of lens combinations. When the light touches this, you will get the colors and it comes out. This is the way, the technology which we have in the projector. Next, you can see some kind of prisms we have, reflecting prisms, which makes a 90 degrees, 90 degrees and also 180 degrees. Right? See here, object, total internal reflection, total internal reflection, total internal reflection concepts. These are the sources. Right? Is total internal reflecting and coming out, total internal reflecting and coming out, total internal reflecting and coming out. These are the some applications. So this is the today's class. Thank you very much.